Good morning, good afternoon, good evening, wherever you are on this planet, and welcome to our SETI Live Citizen Science Q&A. And with me, I have Lauren Sgro. Hello, Lauren.
Hello.
So my name is Franck Marchis. I'm a researcher at the SETI Institute, director of citizen science, and Lauren is an outreach manager at the SETI Institute. She also works on Exoplanet and the science for Unistellar.
Correct.
Okay. So, first of all, welcome. You're welcome to ask us questions about citizen science with Unistellar in the chat questions. We're going to take the time to answer to a few of them. And let's talk about first some recent achievement.
Yeah, let's do it. There's been a lot of really exciting stuff happening in the world of citizen science recently.
So one of the most interesting targets we have in the solar system, just let's restrain to the universe, to the solar system, okay, is of course the Comet A3. The real name is C2023 A3 Chuchi-Chan Atlas, the purple mountain atlas observatory discovered this comet, so that's why it's called like that. So several of you saw this comet naked eyes with your phone, but also with your telescope. And in fact, we have been organizing some kind of contest, right?
Yes, we had a social media contest held over Facebook and Instagram where people from around the world who were taking images of Comet A3 with their Unistellar telescopes were submitting in their favorite images. And we had a couple of winners, one here in California in the US and one in France. So congratulations, Scott and Terry. And I'm actually going to show one of my favorite images that came from this contest. It wasn't an image taken with the telescope, but it was taken next to the telescope, which is pretty cool. This was taken by Takaya Okada in Japan while he was observing, and you can actually see that Comet A3 was naked eye at this point, and he happened to be observing and captured this image with his phone.
And you can see the Milky Way in the background.
It's pretty amazing.
It's pretty cool now because it's crossing the Milky Way. So if you look at it, you will see a lot of very bright stars in the background. But remember, it's now so faint that you need a telescope to be able to observe it.
Yeah.
We have put a web page on our website where you can see a lot of pictures taken with our telescope. Something which has been remarkable for this comet is that we have been following it for 2 years. And we made some predictions, and the prediction happened to be correct. The comet was extremely bright at the opposition. That's mean when it was close to the sun and close to us at the same time. And this is due to some kind of phenomena that we don't generally see that easily on comets because they're not that dusty, which is what we call forward scattering. So the comet has been acting like if it was basically a mirror and reflecting the light of the sun to us. So if you look at our website, you will see some images of the comet. This is taken with an EV-scope probably. You have the one where you can see the anti-tail. That's very silly. You do?
Let's see. I think so.
Yeah, so this is what in the case when the comet is basically close to us, we can also see the dust that the comet ejected through along this path. So that's what we call the anti-tail, roughly. It's basically a line that we will see close to the comet. Mike Prime, I think, got this one, if I remember. I did it too from California. You can see that here at the bottom, the anti-tail. So yeah, that was definitely an interesting target, and we get a lot of observation. We are processing still the data. We continue to observe it and to see how the comet will evolve over time as it's drifting away from us and going to the outer parts of the solar system. It may not come back because his orbit is hyperbolic, if I remember. So
yeah, this is its first visit in I think 80,000 years.
He may not come back because the orbit has been affected. So right. We will see that in the future when there is a better idea of the orbit. But it's it was a beautiful sight. You watched it?
Yes, I actually got to see it. I went to South Georgia, where I'm from, to visit some family and had some dark skies there. Got to see it naked eye, which was really cool. Of course, you had to divert your gaze a little bit in order to see it, but it took up a huge swath of the sky. The tail was just magnificent. So it's the naked eye comet I think we were all waiting for.
Yeah, Okay, another comet. Let's talk about
Yes.
29P.
Yes, we had another very interesting comet situation very recently. So Comet 29P, Swashman-Walkman.
Yes.
I hope that I am saying that correctly, but the jury is out. So this is a centaur transition object, which means that it's kind of somewhere between a comet and an asteroid. It's similar to an asteroid in size. And we've actually been watching this particular comet for a couple of years, actually. We saw it outburst in late 2022. And an outburst is essentially when a comet, which has a predicted brightness, brightens faster than predicted. All of a sudden, it gets really, really bright. And that's usually because there are lots of ices being sublimated all at once, being released from the comet's body. But on November 3rd, it was supposed to be too dim, actually, for unistellar telescopes to even see. And all of a sudden, it got 100 times brighter on November 3rd. And we actually had one of our citizen astronomers who's been doing an awesome job tracking this particular comet. I'm going to pull
Keiichi Fukyu.
Mm-hmm.
Hi, Keiichi. I don't know if you're watching us from Japan.
I hope he is. Hello.
Hello. Yes, so you're gonna see a comet like this far away. It's basically a tiny dot, right? It reflects the lights, and when it has an activity, you will be able to start seeing also that the dot is not a tiny dot. It's blowing, expanded because
exactly.
it ejected the dust and around from the nucleus due to the explosion or whatever is happening on this comet.
So this particular image was taken November 6th, so right after the outburst. And you can see the comet, it's right here in the very center. And if you actually look, it's going to take me just a second to pull this up, hold on.
So it's magnitude 12 on this image, meaning that it's 5 times brighter, is 25 times brighter than he was expecting to be.
Exactly, let's see. And here is actually a more recent observation. So this is taken about 12 days later, just the other night on November 18th. You can actually see how the coma of the comet is expanding and actually appearing larger on the telescope because, as Franck was talking about, it's expanding out after this outburst, after all of this material has been released. So we're just going to keep asking people to keep observing this comet so we can track its outbursts, which are actually thought to be caused by cryovolcanism.
People, you should help Keiichi because he's not going to wake up every night to observe this comet. So we have like a lot of telescope in Japan and everywhere in the northern hemisphere where it's observable. So come on, help Keiichi. Let's observe this comet.
Yeah, he's been like a one-man show.
Yeah.
But this is really cool. So
it's comets like this have this kind of activity. One of the explanations is this kind of volcanic activity from ice. So it's called cryovolcanism because it's a very cool word to use.
I'm not going to lie.
It's very cool. Yeah, cryovolcanism. I tried to say it with the American accent, but it's very difficult.
You're doing great.
I'm doing great? Oh, thank you. She's nice today. Normally, she does not understand me that well.
That is not true. See how he talks to me?
Okay, so 29P is a ball of ice and material, right? It's not, comets are not very homogeneous. So they may have pocket of gas of carbon dioxide or a mix on ice and so on. And those are different temperature where they vaporize, basically. And what happened is that when the heat of the sun reaches the surface, going into the interior of the comet, we may encounter some pocket of volatile elements like gas, and this will vaporize. And sometimes the vaporization is so sudden and expanding, and the pocket expands so quickly that it produces this kind of volcanic activity on the cryovolcanic activity on the surface of a nucleus of a comet. And that's what we are seeing now. When we see a flare like that, an outburst, professional telescopes can just point toward this comet, take a spectrum, so see, for instance, the gas being emitted, and we understand better the composition of the interior of the comet. That's the reason we're doing all of this research, in fact.
So it actually has scientific merit. There is reason.
Talking about scientific merit, can we go to the exoplanet?
We can talk about the exoplanet. First, I wanted to say hello to some people who are who are tuning in. We've got people from Sweden, from California as well. Hello. From Japan. Hi. Hi, Tateki.
Netherlands.
Yeah.
Oh, Tateki
From
Goto is here.
Colorado.
Hi, Tateki. Duluth.
That's literally my mom.
Okay, that's your mom?
Yeah.
Hi. Yeah, thank you everybody for watching us. We are talking about citizen science with the Unistellar network. Okay, so more science.
Yes,
Exoplanets.
More science. So that's my thing. I lead the Exoplanet program with citizen science. And really briefly, I'm going to try to keep this simple. Something that we observe quite often in our work is what's called a planet candidate. So TESS, which is NASA's Transiting Exoplanet Survey Satellite, looks at large portions of the sky and basically watches for stars that are dimming their light so that maybe an exoplanet is passing by, and we can confirm that. So what happens is that TESS looks at particular patches of the sky for about 27 days, and then it moves on. And occasionally it doesn't see more than one or two potential transits for a planet candidate. So it'll see a star's light dim maybe once or twice, but because it's moving around the sky and it's only looking at each part for about a month, it misses maybe some transits in between. So if there's two transits that have been detected by NASA's TESS, we call that a TESS duo candidate. So there's two transits. It may potentially be a planet, but we don't know exactly how long that planet takes to orbit its star because TESS has only seen it do so twice. And it could have maybe missed some potential transits in between the two that it actually observed. So what we try to do with the Unistellar network is to observe potential periods for these candidates. So again, an orbital period for an exoplanet is just how long it takes to orbit its star. We try to look at potential periods that could fit into that time span that TESS was not observing the object. And we actually had a really interesting result not last month, actually, October. Time is not real. It feels like it's still. Oh wait, is it December? It's November. It was last month.
Yeah, I was October. Like, what she's talking about?
Look,
you already in December. You're in a rush to get Christmas presents.
That's exactly right. No, I'm in a rush to observe this because we'll actually get to observe it again in December.
So that's the transit of the transit of an exoplanet called TOI 5571.01.
So this is one of our duo candidates, a potential planet, and we happen to observe it during this window where it may have a period that is corresponding to 36 days.
And you see a detection.
So yes, but it needs to be followed up. This particular window could essentially narrow down a few different periods, actually. The one that we're going to look at this December would correspond to a period of 36 days. But this potential detection tells us that there's more to look at. So we want to start looking at the potential periods that would be indicated by this detection.
Okay,
it's a little iffy to.
So basically, you have a candidate of detection here. You want to confirm.
We want to confirm it, and we want
this. If it's confirmed, it's going to confirm the existence of this exoplanet.
Exactly.
So in short, you're gonna be discovering an exoplanet if you do this observation.
Yes, hopefully, and we'll be able to actually determine which period corresponds to this planet. And this is similar. A little bit to some of the other planet confirmations that we've had this year, which I think we've been a part of 3 or 4, which is really, really great.
Yeah. Okay, let me say hi to people from Springdale, Arkansas. I'm assuming Texas. So many people from Texas.
Hi, Texas.
Detroit, Huntsville, Alabama, Toms River, New Jersey. I love this name. This is cool. And I saw someone from Brazil and Netherlands. So thank you. We're talking about citizen science with the Unistellar network and in collaboration with the SETI Institute. So are we done with this for the exoplanet results?
Oh, wow.
Yeah.
I guess
It's
so.
there.
He
It's
really
good.
does not
I
want to
li-
talk about exoplanets anymore.
No, I like it. I like it. I just would like next time to have a picture. Why don't we have a picture of an exoplanet? Why is that possible to see an exoplanet?
Well, for one, their host stars are so bright. So it's really hard to directly image an exoplanet. You need very sensitive equipment, which I think that you helped work on at one point.
That was a tricky question. I just wanted to see if you're gonna mention that we have observed and detected a few exoplanets, in fact.
In direct imaging. We have to block out the light from the host star in order to do that.
Okay. Let's talk about something very different. We go back to the solar system. A lot of things in the solar system recently. So we have a very cool occultation by an asteroid called Lachesis. I'm saying it like this, and I'm sure you say it differently. How you would say it?
I have literally no idea.
No idea? Okay.
I have no clue.
Lachesis is the asteroid number 120. So when we started observing asteroids, we started numbering them. So now we have reached to the million. But this is 120. So it's probably one of the closest and the brightest and the largest asteroid because it's one of the first to be discovered, the 120th to be discovered. Well, this asteroid, which is orbiting in the main belt, was predicted to occult a bright star. And this event was observable in a line from Greece, Italy, Spain, south of Spain, and south of Portugal. So we send an alert to our users in this area, in those countries. And the event was happening on November 13th. And what's very important is that because of the combination of the motion of Earth and the motion of the asteroid, basically this occultation was predicted to last for a very long time. 36
seconds.
36 seconds.
Yeah.
Most occultation lasts like what? 200 milliseconds, 1 second. That's the average.
Yeah.
So here is what happened is that Earth was moving and the asteroid was moving probably in the same kind of geometry and direction. So that make the occultation last for a long period of time. Because what you see, remind you, is the shadow of the asteroid passing on Earth. So we made this alert and we got one detection from Stephen Atkinson.
Yeah, this is really cool. Yeah, I'm showing it now.
I didn't see it yet, so.
Oh, okay. So it's going to be a surprise to you too. I'll fast forward so we can see, but this is
of course the circle shows the star that's going to be occulted. So we predict more or less when this will happen. We ask our user to observe a few minutes before, a few minutes after, because there is always a random moment, and watch the circle, and the star disappear. And this is an accelerated movie. This is a thing accelerated 10 times or something like that. This event lasted 36 seconds. So for half a minute or more, and more, Stephen did not see this star.
Mm-hmm.
Those are very cool because those occultations allow us to estimate the size of the asteroid. So we're doing the analysis at the moment, but this is a large asteroid, typically 150 kilometers in diameter. And what I really like, I don't say that often to people, is that those observations are interesting because if there is a moon around this asteroid, we may be able to detect it doing these observations.
Yeah.
That's why we observe before and after in the hope of detecting a secondary occultation that will suggest the presence of a moon around an asteroid. That's pretty cool.
We've done that before at some point in the network's past, a couple years ago.
But for some moons that we know they existed, not for searching moons.
Right.
We have not yet discovered a moon with the Unistellar SETI Institute Citizen Science Network, but it will happen. Okay. So we have a question. We have more than that, but there is something we prepare. So a lot of you ask, how can you join the citizen science? And some of you mentioned that they're kind of confused. So we're gonna try, and this is very trying a live attempt, to show you how you can join the network. Are you ready?
Yes,
yeah?
I am. Yes.
So we're gonna do first. I explain first the registration. Yeah.
Yes, I'm going.
So you're gonna share your window, and I'm gonna try to comment, and you can interrupt me as well.
Interrupting. That's my favorite pastime.
I know. Let me say hi to people from Jackson, Michigan, Arlington, Virginia, and Mario is traveling. Hey, Mario. Sao Paulo, Brazil, and London. I think it's London, UK. I don't think it's London, Texas. You ready?
I am.
Okay, so Right now, you're sharing your screen, which is our page, citizenscience.unistellar.com. So you can do that on the app too, but now you can also do that directly on our website.
Mm-hmm.
You go to the More section, and in the More section, all the way at the bottom, there is a text that says,
Join us.
Join us.
Join the club.
Join the club. To join the club, you just need to read this text here, explaining briefly how it works, and then you fill up this form. So this form, we ask you what? Name,
email,
name of the telescope,
mm-hmm.
and also if you're a member of the AAVSO observer, AAVSO observer code if you're a member of the AAVSO, and
which is the American Association of Variable Stars.
And then we ask your country, your city, and the zip code. This is useful to help our predictions, for instance.
Mm-hmm.
We don't share this information with anybody. This is really strictly for the citizen science program. You press submit, and you may receive a confirmation that your application has been submitted by email, and then you wait. And that's the part which is probably people don't realize, that every Monday, we go through the list of all the people that register, and we will add them to a Slack channel. To be added to a Slack channel, you're going to receive an email from Citizen Science
mm-hmm.
with a link. You click on the link. You have this email, I'm sure.
I do. I did have the email, but I want to open my personal email.
So yeah, because we're doing a test on your personal account. So you're going to click on the link, mm-hmm. and you're going to go to this page, Join Unistellar on Slack.
So when you get that link, sometimes it's important to check if you haven't received it in about a week, definitely check your junk email. It's gonna say that we're inviting you to join Unistellar on Slack. You'll get that email, and it's gonna just have a button, and you just press that button. It'll take you to this page. So
you fill up the page.
Information. God.
Great.
I'm trying so
this
hard.
is why we don't want to do it live. We love working in a risky situation. So you register, welcome to Unistellar, and then again,
it's going to ask. I have the Slack app downloaded on my computer, so it'll ask me if I want to open Slack. Let's see. And this is going to be my introduction to the network. I'm going to have to share my Slack screen real quick, so let me do that. Now it is taking me.
So now we're switching to another application. Okay,
mm-hmm.
We went from the web to the Slack to a Slack app that you downloaded,
mm-hmm.
and
oh gosh, I have so many windows. There we go. And this is what it will look like.
So you are going to see that you are joining a Slack. So Slack has the structure that of most systems to chat. There is channels. So you have predefined channels that you have access to. The one to visit first is the welcome one that explains basically what's going on, what are more or less each channel and what they do. Then after that, you go to general to get a flavor about the activity, the conversation. Today, Margaret posted a poem. Thank you.
She did. It was actually really beautiful.
Thank you.
So if she's watching, great job. You're fantastic.
So we have different type of posts on general. People tell what they do, or when they join, or etc., etc. We post some information as well when there is some significant result or significant campaigns.
Mm-hmm.
And then you're gonna go to the channels. So for instance, if you're interested in Comet, guess where you're gonna go?
You will go to the Comets channel.
Yeah. And in the Comet channel, you have kind of first, in this case, we just posted Monday, we posted the statistic of what happened this week. So you have the number of observation this week, 24 observation, and then per target. And you can get as well.
You can also have
you can have help and so
you.
on. Something you're gonna also receive is an invitation to the channel called, in this case, 2024 November, where you're gonna meet all the people who joined the channel, who joined the Citizen Science in November, and we can interact with us directly. So this way we can explain a bit more about each channel, what they do, answer to some questions. So you don't have to ask the question in general. You don't feel comfortable to talk to people you don't know about. There is 2,000 people, no more, 3,000 people.
2,500 people.
2,500 people.
2,500 citizen scientists signed up.
So it's a nice community. There is some fun channels too to discuss, to show pictures, to show spectra. Did you know that you can take spectrum with the Unistellar telescope? But if you didn't know, you should go to the Slack channel, because that's where we explain how to do that. And there is channels to discuss some random thoughts and share some random ideas. So it's a cool community. It's another one, citizen science community. If you want to join this big community of Unistellar, I also recommend you go to the Facebook community page, by the way. This is where you are going to also meet people. And there is not always an overlap between those two communities, because there is different type of interest. Did I say everything we should talk about this?
I think the only thing is that if you are signing up, and you see all of the channels to your left, which should include all of the main science channels. So that would be planetary defense, exoplanet transits, favorite, comets, cosmic cataclysms, which is transient events like supernovae, other types of explosions in space. You'll see those, but if you're interested in other channels, you can always go to browse all channels. It can, it's a fantastic resource, but sometimes we find it best to just kind of like dip your toes in the water and start off with those initial channels that we just showed you, general and the main science channels. Yeah,
sometimes, for instance, when we do a campaign, like when we did the JWST observations during the launch, we created a channel JWST, so we can see the history of this channel, what happened in the past, and so on. And we will open new one when we do large campaigns. I mean, sometimes we open one even for exoplanets when there is something super interesting. Yeah. Even.
And there's always super interesting stuff with exoplanets.
Yeah. And if you go to the one for cosmic cataclysm, this is a very cool channel because it's extremely active. You will see that you have alerts when something is being detected, like a new flash of light in the sky. Boom! It will be posted right away into the Cosmic Cataclysm channel. If TCOR finally wakes up, we will have an alert on this channel, but also in general. I think I asked Tom to put also in general. Okay.
So we actually, so basically to summarize that, you will go to our website, go to that Join Us tab on science.unistellar.com, fill out a quick Google form. You'll get an email in a week. It's time at maximum, and then you click that link, and then you're automatically part of our community. So there are also examples.
You can stop sharing. We need to wrap up.
We actually have one question that I would like to bring up really quickly.
Go ahead.
Yeah, thank you for asking, Mike Edwards. This will be our last question. Is it possible to observe a variable star with a period of a few hours or less on a site like the Exoplanet bot? The period would look like a sine wave, I assume. Yes. So what Mike Edwards is asking, thanks for the question, is basically, can we use the resources, the sets of computer code that we use to process exoplanet data? Can we use that to also process data from variable stars, which have light that varies on, in this case that he's asking about, a few hours. Sometimes it's, days to years. But yes, that would be possible. We wouldn't be able to essentially model it like we do with a exoplanet in order to get exoplanet parameters from the data that you submit. But we could definitely use those resources to process that data, and we would just have to treat it a little bit differently. So we could absolutely see that sine wave, but we wouldn't be able to fit a model that tells us more about the planet because it's not a planet.
Yeah.
Okay. But we can talk offline.
There is a question from Zapfan. I think he's asking about GPI.
Yes.
This isn't related to citizen science, but since it's a question related to the project I've been working on. So GPI, the Gemini Planet Imager, it's an adaptive optic system on the 8-meter class telescope that is capable of imaging young Jupiter exoplanet. So see an exoplanet, but see it, like not detect the shadow, see the planet in orbit around the star. So, well, GPI is been removed from the Gemini South telescope, is now being refurbished, improved, and getting much better capabilities at University of Notre Dame. I don't know how to say it in English.
You did great.
American,
that
sorry.
was it. That's great.
I cannot pretend this one. And University of Notre Dame is working on making the system better, as I mentioned, with the team. Some of us are still involved. I'm involved still. And we hope to be on the sky of the northern hemisphere sky in Hawaii, Mauna Kea, next year, I think, if I remember properly the timeline. So we're going to start the survey in the northern hemisphere next year with the same instrument. So we may see more exoplanets.
That would be exciting, and see them for real.
Okay, I have a question for you before we wrap up.
Okay. What is this mystery question?
The mystery question. So what happened last night? Where were you?
We were at the SETI Institute's 40th anniversary event. Yesterday marked to the day the 40th anniversary of the SETI Institute, being born, and it was fantastic.
So who did you see there? Beside me, of course.
Because, I see you all the time, and it's still great. But we brought the Unistellar telescope. We showed some people, and we had some remote observers tune in to show their observations.
Thank you.
Yes, thank you so much. It was fantastic. But we got to see Jill Tarter herself.
Yeah, because she got an award.
She got an award that is named after her, the Jill Tarter Award, and she, of course, won the inaugural award, as she should, and gave a fantastic speech. And people from all over kind of tuned in to congratulate her, and it was really inspiring. I got to meet her and froze because she
didn't want to talk to her.
She's such an inspiration.
It's the first time I see her and not wanted to talk to someone because she was like.
I was nervous. She's so very, very kind and so well spoken and lovely, but I was just so scared because she's so inspiring.
Yeah, and the award is called the Jill Tarter Innovation Award. The idea is to give an award to astronomers, astrobiologists, SETI Institute researchers who work in the field of innovation for space exploration. So there will be more of those in the future. And yeah, for me, it was emotional to see Jill and hear her talking about. We have an amazing movie, a short movie about her life that was shown for the first time. There was a lot of very cool people from NASA, from everywhere in the world, ex-employees that came back of the SETI Institute, people that I have not seen for 10 years, decade even. One of them is Brenda. I don't know if you know who's Brenda. Brenda used to be the direct assistant of Frank Drake. And when people like me used to apply to the SETI Institute, we had an interview with Frank and Brenda. That was the job. That was the way you could get the job. And Brenda has a lot of stories about the first time she saw myself and other researchers that now work at the SETI Institute, like Nathalie Cabral. And the first conversation she had with us, she remembers that, and she was mentioning that to me.
That's pretty cool.
Cool.
That's fantastic. Yeah, it was just to know what Jill has done for this field, and to be able to honor that was really inspiring.
Okay, we're going to end it here. We're going to take more questions next time.
Mm-hmm.
Okay. This was a SETI Live on Citizen Science with the Unistellar and SETI Institute. Thank you very much to everybody. You know that you can see a replay of this video on every platform. If you want to support us, you can simply write a comment, press play, press like, join us on our social media platforms. You can also register at SETI.org to receive our newsletter called Journey. And if you want to support the research at the SETI Institute or our outreach program like this one, you can make a small donation. Just click on donate on the top right of the website. And thank you again. We hope to see you in a month for a similar Q&A. Lauren?
Yes,
see
of
you
course.
In a month.
I'll see you in a month.
Okay.
I mean, I'll see you in about 5
She
minutes.
cannot wait for Christmas. I think we're gonna do it just before Christmas.
Fantastic.
Okay. Cool.
I love that.
Thank you again.
Have a great day.
Bye.
Or night.